So for question 8, we are given 15 grams of methanol, and we're solving for grams of water. First, we have to write our equation. Methanol plus oxygen gives us carbon dioxide and water. We have an even number of hydrogens over here. We have one carbon. We have 4 hydrogens, so I'm going to put a 2 there. This gives me 2 oxygens and 2 oxygens here. But over here I have 2 oxygens plus 1. This is going to have to end up as an even number. So now I'm just going to go through and multiply everything by 2. That's going to make this guy 2. That's going to make this guy 4. Now I have 4 oxygens plus 4 oxygens, which adds up to 8. I have 2, so this guy is going to have to be 6, which means he'll be 3. All right. Starting with 15 grams of methanol. The molar mass of methanol is 32 grams in 1 mole. The ratio of methanol to water is 4 waters to 2 methanols. And then we want grams, so we multiply by 18 grams in 1 mole. Number 9, we're going to talk about titrations. Starting, we know we have 0.525 grams of silver chloride, and we're solving for volume of barium chloride, and it gives us a molarity. So if we look at our mole map, we've got grams to start. Erase this and start over. We've got grams to start. We divide by molar mass. We go through the mole ratio. And then we're solving for volume, so we'll divide by molarity. Got to write our equation first. Silver chloride is formed by mixing silver nitrate and barium chloride. Silver chloride plus barium nitrate. Okay, we need, no, not a 2 there. Oh, I wrote that wrong. AgCl, not AgCl2. We need a 2 here, and we need a 2 here. All right. We know 0.525 grams of silver chloride. The molar mass of silver chloride I've already worked once. It's 143.32 grams in 1 mole. I'm going to make 2 moles of silver chloride for every 1 mole, 2 to 1 or 1 to 2 of barium chloride. And the molar mass of barium chloride, 208.23. No, but we don't need molar mass. That's not what we're solving for. We want volume. So if I am at moles of barium chloride, and I want to go from moles to volume, what do? I divide by molarity. So, now we're going to divide by the molarity, which was 1.50 And the units are moles. So we're dividing, so we put 1 liter on top. Grams cancels, moles cancels, moles cancels. We have an answer in liters. Okay? Number 10. It tells us, it's asking for, I'm going to do green first, what is the molarity of barium chloride? So this is our unknown, and it gives us a volume. So our known amount, it tells us we have 18.55 milliliters of silver nitrate, and it tells us molarity. Can we find moles with that information? Sure we can, but first we have to write our equation. Barium chloride plus silver nitrate. Gosh, this looks familiar. It's the same equation. Okay. So we start with what we know. I'm going to change liters to moles. Milliliters to liters. 0.1855 liters. My molarity is 0.150 moles over liters. Silver nitrate, we have 2 moles of our known, and that's going to react with 1 mole of barium chloride. And we're going to change to molarity, and to find molarity we have to divide by volume, and our volume that's given is 0.25 liters. Okay? Lead ions can be precipitated from aqueous solutions by the addition of aqueous hydroiodic acid. How many milliliters? So we're solving for hydrogen iodide, hydroiodic acid, and we're given volume and molarity of lead nitrate. So we're going to mix lead nitrate plus hydroiodic acid. The hydrogen and the lead will switch places, which means we'll have nitric acid and we'll have lead iodide. So we'll need a 2 here and a 2 there. Starting with what we know, we have 2.8 liters and 0.25 moles per liter of lead nitrate. The ratio lead nitrate to hydroiodic acid is 2 moles of HI over 1 mole of lead nitrate. Now we're in moles of hydroiodic, and we want to know volume. So to find volume, we have to divide by the molarity. That's going to give you an answer in liters, and it's asking for milliliters. So then you would just divide by, or multiply by 1,000 to go back to liters. When milliliters divide by 1,000. No, multiply. I was right. Okay. Although I can read either one.